All right, dear students, let's take a look at week 24's homework. We're getting into the meat of Unit 5 here, and we're getting into how to really understand fraction. Okay, let's read the first question. Which two students ate the same amount of cake? So, you should understand that the shaded part like this represents how much cake was eaten. Okay, so the question wants us to figure out which two students ate the same amount of cake. So let's just take a look at it. Sarai ate how much? The whole cake was divided into two pieces, so that goes in the denominator. She ate half of it, that goes in the numerator. How about Robin? Robin's cake was divided into four pieces, right? One, two, three, and four. And she ate how much of it? She ate one out of the four pieces. Maddox's cake was divided into one, two, three, four, five, six, seven, eight. Eight pieces, so eight go on the denominator. How many pieces did she eat? One, two, three, four. So four pieces. For London, there are totally one, two, three pieces, and London end up eating one of them. So the question is asking you which two of these fractions are the same. So how do we look at them? All right. For one half, one fourth, and one third, they are not the same at all because on top the numerator are all ones. See this? And denominators are different. The dimension of these three cakes are also very different. However, if you look at just how much was actually eaten, see how this is half of the cake? One half? You see 4 over 8 is also half of the cake. So although these two fractions are, they have different numbers, but they stood for the same value. What I mean by that is 1/2 is the same as 4 over 8. Now, you have to understand when you are changing a fraction, okay? You can multiply the top and the bottom by the same answer. Then the value of this does not change. Okay, A can be 1, 2, 3, 4, 5, whatever, any number you like. So for this case, 1/2 was multiplied by 4 on the top and 4 on the bottom. Now, why can you multiply, 1/2 by 4 over 4 and the value of this number would still remain the same because 4 over 4 is the same as 1. Remember we learned that 2 over 2 is 1. 3 over 3 is 1. So when you're multiplying any fraction by 1, you get the same fraction, except when you multiply 1/2 by 4 over 4, the way this fraction looks did change. So the top become 4, 2 times 4 is 8, see, 4 over 8. That is why Sarai and Maddox should be our answer, and that is A. And that's how you do number 1. And please, if you don't understand this, you got to ask. All right, this is not an easy concept for you to grasp. All right, let's take a look at number 2. Number 2 says, look at the following number line. Which of the following points show equivalent fractions? Equivalent, you should understand, this means the same. The easiest way to do this is just to draw a line lining up the top and bottom. Anything that is lined up are the same. Like B and G are the same. D and H are the same. F and I are the same. You can't really line E up with anything because it's obviously at a different point on the number line. Same with C, same with A. So anything with A, C, and E in it automatically are wrong. So, I see A, C, C. I know A, B, C are all wrong because for this type of questions, A and C doesn't make sense because it's not lined up perfectly with any points on the second number line. Therefore, I don't even have to look at this. I already know D is the correct answer. And that is the easiest way to think about question number 2. Let's take a look at number 3. Number 3 is just like number 2, right? We just talked about that, didn't we? See that? D and J, F and K, I and, sorry, H and I. Oh, sorry, this is L. I don't know what I'm thinking. All right, so if answer choices doesn't have these two four combinations, they're not correct. A and I, no. B and I, there you go. See this? That's gonna be our correct answer. Okay, not that difficult to figure out. You just have to line the points up and make sure that the letter on top and bottom are all present in your answer, right? Because it's talking about equivalent fraction. Equivalent fraction means these two will line up. If they don't line up, then they're not equivalent. See? All right. So let's take a look at number 4. Number 4 is also a very interesting question. Renaya bought a rectangular candy bar from the store. While at her friend's house, she decided to share the candy bar with her friend Iliana. Then Iliana's younger brother Isaac decided that he wanted a piece of the candy bar also. If Renaya shared the candy bar with only Iliana, how much candy would each girl receive? Would they piece would they get a Would their piece be bigger or smaller than if they shared the candy bar with Isaac also? So we have one piece of candy bar, right? If Renaya and Iliana were to share it, it's very simple. You break the bar in half. Each one get one half of the candy bar, right? Now, what did the question say? It says if Renaya shared the candy bar with only Iliana, right? How much would she receive? So if she only shared with Iliana, then the girls would each get one half of the candy bar. Now, the second part of the question says, would their piece be bigger or smaller than if they shared it with Isaac also? So if the same candy bar, instead of sharing it with just Iliana, we're sharing it with Iliana and Isaac, then you would each get a third of the candy bar, right? Remember, 3 is the number of pieces that was broken down into, and 1 is how much one person would get. So which number is bigger, 1/2 or 1/3? This is what they're asking you to figure out. Look at it. Which one's bigger? 1/2 is definitely bigger than 1/3. Therefore, which one of our answer choices makes sense? I can already tell. I see 1/3 here, 1/3 here. Remember, if Renaya is only sharing with Iliana, then they each get 1/2. Therefore, C and D are both out of the running. A and B is left. Now, how are they different? They're different by the word bigger and smaller. So the last part of the question is the their pieces would be bigger if they also share the bar with Isaac. Now, is that true? No. We just drew the candy bar and we saw it, the pieces would actually be smaller if they shared it with more people. This is an obvious thing. You should realize that. Think about it this way. Like you're sitting there at lunch, right? You have 4 pieces of chicken nugget. If you get to eat all 4 pieces, then by yourself you eat 4 pieces. But if you want to split it with your friend, if you split it with one friend, each one of you get 2. But if you split it with 4 friends, everyone can only get 1. So the more you split something, the fewer each person will get. That is the idea here. And that's how you solve number 4. Let's take a look at number 5. All right. Number 5 says, Write an equivalent fraction to 1/2. Okay, so 1/2 is 1 over 2. The easiest way to solve a equivalent question is just multiply top by 2 and the bottom by 2. Remember this is going to be equivalent because essentially we're just multiplying 1/2 by 1 because 1 equals 2 over 2. Okay, so what is 2 times 1? That is going to be 2. How about 2 times 2? That's 4. So 1/2 is the same as 2 over 4. Now, you're going to write that. Okay, that's what I want to see in the blank right here. The second part says, draw a visual fraction mode to show why the two fractions are equivalent. Okay, you can do um, many different things, but I usually just draw a rectangular box. Then I draw the same rectangular box. The first one I divided into half. Then I shaded. The second one I divided into fourth. And I also shaded. See how the shaded area are really the same? This area equals this area. So that's why they are the same. And that is also why 1/2 equals 1/4. The last part says explain your thinking. You can just say I timed 1/2 by 1. Since 1 is the same as 2 over 2, 1/2 times 2 over 2 is 2 over 4, and 2 over 4 is the same as 1 over 2, or 1/2. All right, that's what you could say, because that's what you did in part A. You multiplied 1/2 by 2 over 2. You did that because you didn't want to change the number. 1/2 times 1 is also always going to be 1/2, and 1 is 2 over 2. So that's why 1/2 equals 2 over 4, and that's why you can write that. And that's how you solve number 5. Let's take a look at number 6. Oops. Number 6 says, which of the following shows equivalent fraction? So equivalent fraction means the two pictures represents the same value. Now let's take a look at A. Okay, one of the three part is shaded. So the first one represents 1/3. The second one represents 2/3 because two of the three pieces are shaded. Now, are they the same? No, they're not the same. That's why A is incorrect. Let's take a look at B. How many equal pieces did this rectangle get split into? That's 1, 2, 3, 4, 5 on top, 5 on the bottom. So that's a total of 10. 5 out of those are shaded. The left half is 5 over 10. How about the right half? Same 10 pieces, but this time only 2 are shaded. 5/10 and 2/10 are not the same, therefore B is also incorrect. Let's take a look at C. C, the rectangle is being broken into 4 pieces, and we have one shaded part. On the right side, however, it's been broken into 8 pieces, and there are 3 shaded parts. Obviously, 1/4 and 3/8 are not the same. See, this 3 big pieces is bigger than that one piece. Okay, and if you want to compare them, you can just pretty easily tell they're not the same. The last one is D. D says this is 4, but instead 2 are shaded. Over here we have 4 pieces shaded out of 8 pieces. Now this one is actually the correct answer. If you look at the dimension of the shaded part, this shaded part is actually the same size as that. To go a step further, remember I told you 2 over 4 times 1 would still be 2 over 4, and 1 is the same as 2 over 2. So 2 over 4 times 2 over 2 will not change the value. 2 times 2 on top is 4. 2 times 4 on the denominator side is 8. See how that is the same number as the shape on the right side. That is why D is correct. It's explaining why you selected the option. You can write because, okay, um, 2 over 4 is the same as 4 over 8. 2 over 4 times 2 over 2 is 4 over 8. Okay? In the future, I'm sorry about that. Write this out. Just write times. And that would have been better. And that's how you do number 6. Let's take a look at number 7. Number 7, very familiar question. We have looked at questions like this every single unit since unit 1. So it says Kanaya took a survey of third graders' favorite school subject. The results are shown in the picture graph below. The picture graph says our favorite school subject, and the key says each pencil equals 4 students. The question is, which question cannot be answered from the data shown above? So A says, which 2 subjects do third graders like the least? Can we tell which 2 it is? Obviously, because the answer is PE, right? And reading slash ELA, because they both only got 2 pencils. How about B? B says how many students participated in the survey. Now we can also find that information. We can just add all the pencils up and multiply by 4 because each pencil represents 4 students. So we can also figure out B from the graph. So they're not the correct answer because we're trying to figure out which one cannot be answered. C says, what is London's favorite subject? Now, can we tell which pencil or what London picked? No, we can't, right? From this graph, we can only tell something about the whole school, everyone in the school, what they liked, not what London liked. Because how can you tell, which pencil represented London's pick? You cannot tell that piece of information. Therefore, C is the correct answer. Okay, that's how you do number 7. Let's take a look at number 8. I should make this a little smaller. Too much. Okay, this is pretty much as good as we are going to get. Okay, this is good enough. Number 8 says, at the end of the football season, 6 players on the Tigers football team recorded the number of points that each of them scored during the season. The number of points that 5 of them scored is shown below. If Gary scored 18 more points during the season than Jamari, which of the following would correctly show the number of points Gary scored during the season? So, where is Jamari? Jamari is right here. So he's got 3 football, right? Each one is 6 points. So if Gary scored 18 more points, we have to figure out how many more football Gary's picture would have. So if each one is 6 points, 6 times what gave us 18? Just count by 6. 6, 12, 18. We counted 3 times, therefore the answer is 3. 6 times 3 give you 18. So Gary, if Gary would already have that 3 football, Jamari, scored, and then he would have 3 additional footballs in his picture. So in a total, 6 footballs. Which answer choices had 6 footballs? It's B. See? That is why B is the correct answer. And that's how you solve number 8. Let's take a look at number 9. All right. Number 9 says, Johnny took a survey of the types of pets students in third grade have at home. Below is a table of his results. The question says, use the survey results above to create a pictograph and key of the data. Explain how you created your key for the data. So we first need to figure out how many dogs each, people liked. For dog, that's 3. You can just see 1, 2, 3. For rabbits, 15, because each one of those sets represents 5. For cats, we have 5, 10, 11, and 12. For fish, we have 5, 6, 7, 8, 9. And for birds, we have 5 plus 1, 6. So let's put these 3, right over here. Just by the look of it, I can already tell all these numbers are multiples of 3 because this is 3 times 1 gave me that, 3 times 5 gave me 15, 3 times 4. Let me write this over. This was not well done by your teacher. 3 times 1, 3 times 5, 3 times 4 gave me 12, 3 times 3 gave me 9, 3 times 2 give me 6. So all the numbers on the far right side, they are how many, whatever we want to draw. Okay, so let's see we're going to draw a graph. Okay, this graph doesn't have to be complicated. Let's just put this pretty much the same as, the one right above you. So we're going to draw a box like this. Okay, and we need, uh, okay, we have pets over here. And then we have number of pets. Okay, we're gonna cut it off right here. The first one is dog. And then the second one will be rabbit. Third one will be cats. Then we have fish. And lastly, we have birds. And we're gonna use a key, okay? What are we drawing? Let's just use circle. Each circle represents how many? 3 animals. Why? Because all these numbers are multiples of 3. So 3 is the best one to use when we're representing these sets of animals. How many circles do we want to draw for dogs? Since there are only 3, we draw 1 circle. For rabbits, we draw 5. See, right here. 1, 2, 3, 4, 5. For cats, we're going to draw 4. 1, 2, 3, 4. For fish, we're going to draw 3. And for birds, we're going to draw 2. And that really is our, our data, our little graph. Now, how did you find the key? You can write this in many different ways, but I prefer to say, I found the key to be 3 because 3 is the or a multiple of all 5 animals. And that's your explanation for how you find the key. All right, that's how you do number 9. Again, this is actually not easy. This is pretty difficult for you to think and understand. So, but that's how you do it. Let's take a look at number 10. Okay, let me start this assignment over. Last question. Okay, number 10 is not difficult, but this question on the benchmark test, not a single person in the class actually did well on this question. Everybody basically missed it. Only several people got one partial part correct. Most of you missed all of it. That's why we're doing this. Let's read it. Miss Williams baked 24 cookies as a reward for her students. She has 2 students who have done all of their reading homework and earned the reward, and 2 students who have completed all their math homework and earned their reward. The first part says write an equation using C to represent the total number of cookies each student will receive if they share all 24 cookies. So how many kids do we have? We have 2 plus 2, which is 4 kids, right? If there are 24 cookies in all, and we have 4 of them, then 4 multiplied by C will give us 24 cookies. That should be your equation. I don't understand how come only 3 people got this part right. Okay? There are only 4 people and there are 24 cookies. So 4 times C give you 24. You could also write it this way. 24 divide by 4 equals C. Both would be fine because you have 24 pieces of cookies and 4 people are splitting it equally, right? Therefore, you can write either or. They both would be correct, but very few of you understood that. Let's take a look at the second part. The second part says, how many cookies will each student receive? All you have to do is just solve it. What is actually C? Count by 4. 4, 8, 12, 16, 20, 24. How many times did you count? That's 6 times. So you will write each student will get 6 cookies. Okay? And for the third part, it says, before Miss Williams passes out the cookies, 2 more students turn in their math homework for the week. Write a new equation using C to represent the total number of cookies each student will receive. Explain how it should be 2 additional students will affect the total number of cookies each student will receive. So, if we had 4 people who turned in their homework. Now, 2 more students turned in their homework. Now the total number is 6. Our equation just, all it changes is just that 6. Okay? See that? See? 24 divides 6 equals C. So what do you have to do to explain? You just write, the question says explain how the 2 additional students should be 2. Additional students will affect the total number of cookies each person will get. You say 2 more students will decrease the number of cookies each student get. Okay? Why? Because you have more people to split the same number of cookies. Simple explanation to the point. And that's how you do number 10. Please, please, please be careful with questions like this. Questions like this truly test whether you could, use the knowledge you have learned to apply to a new situation. If you can't do that, then you haven't really mastered the standards we have taught you. Do your best on this work. Have a good day.